I'm going to try and model this problem exactly the way I would want you to do it on the test. So in this one, this is a projectile launched at an angle. It says that the particular club, the maximum speed that a golfer can impart to a ball is 109 meters per second. How much time does the ball spend in the air? So for part A, I'm solving for time. And I would say most of the time, if I'm looking for time, I'm going to be using my y-facts, especially in a projectile launch at an angle. So I know that the picture, if I draw a picture here, just so I can justify why I'm using sine and cosine, I know that I'm going to put it, because I'm looking at part B here, and it says, what's the longest hole in one that the golfer can make if the ball does not roll when it hits the green? So actually, yeah, because I sort of need to know that, because if the question ended after part A, it really wouldn't make any sense, because it's dependent on the angle. So how long it's in the air is dependent on the angle. I mean, I could hit it straight up in the air, but I sort of have to read part B to know what the angle is, because we want the longest hole in one, and the longest hole in one is going to happen at what angle? 45 degrees. So that means that there's my picture. And this is going to be my VOX. This is going to be my VOY. This is going to be my VO. And there is my angle. So I only need that just so I can justify. This is why I'm saying it's VO times the sine of the angle, or it's VO times the cosine of the angle, because I have a picture here that shows that. Yes? Right, because it says the longest hole in one that you can make. Because if you went at 40 degrees or 50 degrees, it would fall short of that. So 45 in the absence of air resistance is the maximum distance that a golf ball will go. And even if you mathematically would have figured it out for 44 and 46, you would get smaller values for S subscript X than at 45.
So you can pull that from,
Right, right. I mean, if like I told you, if I stop reading right here, then I can't really solve the problem, because I don't have enough information. So it really, when it says how much time does the ball spend in the air, I put it as the first question, but somewhere I should have probably had longest hole, maximum speed, and I probably should have had longest hole in the original problem. But the reason why I put the time is because that I have to solve for that first. So I tried to put it in the order that they would have to be solved. So I know that I'm probably going to use the y-facts to get the time, so that's what I'm going to do here. So my free fact is the acceleration, because I know that things accelerate due to gravity, and that is negative 9.8 meters per second squared. I also can get my VOI, because my VOI is going to be VO. Now, if you look at the picture here, VOI is the opposite side from this angle, so it's going to be the sine. If it was this, it would be the cosine. But I'm looking for VOI, so it's going to be VO times the sine of the angle, and that's going to be 109 meters per second times the sine of 45 degrees. The good thing about 45 degrees is once I solve this, I know that the other component will also be the same answer, because the sine of 45 is the same thing as the cosine of 45. So I know that for 45 degrees, these two will be the same number. So this is going to be 109 times the sine of 45. What is it? Okay, so to three significant digits, we'll say 77.1 meters per second. And I think I told you on this problem, we're going to get a crazy answer that's not really going to make sense. And that's because this original problem, this number right here, was given in kilometers per hour. And I just to make it so you wouldn't have to do a conversion, I just changed that to meters per second. So now, where we can assume in this problem that the golf ball is on the ground, and the hole is up, so the ball is going to go from ground back to ground, level ground. If I was shooting to an elevated tee, or if I was shooting from the top of a hill down to a lower green, then I wouldn't be able to say that the final velocity in the y direction is the negative of the original velocity. I would not be able to say this if it's not coming back down to the same level that it was hit at. So I do know, though, that this is going to be negative 77.1 meters per second in this problem. So with those facts, I can use those facts to solve for the time. So, and I'll do the facts over here to try and save some room. I'll put the equation down. If those are my facts, then the equation is VFY equals VOY plus AYT. And I'm solving for time. So time is going to be VFY minus VOY over AY if I rearrange the equation. So plugging in the numbers, time is going to be VFY minus VOY over AY. So VFY is negative 77.1 meters per second. VOY is positive 77.1 meters per second. And the acceleration is negative 9.8 meters per second squared. I will get seconds as my answer because the whole top is in meters per second. The bottom is in meters per second squared. So the meters will cancel out, and I'll have seconds divided by seconds squared. One of the seconds will cancel, and I'll have second in the denominator of a denominator. That's going to give me the correct answer. And this answer came out to be 15.7 seconds. So 15.7 seconds. Now, part B says, what's the longest hole-in-one that the golfer can make? So that's going to be my SX, because that's horizontal distance. So I'll use a different color here. So for part B, I want my X facts. So I am going to write down my facts in the X direction. The unknown is going to be SX. AX we always know as 0 because we ignore air resistance. VOX I know is actually going to be VO times the cosine of the angle, but the angle is 45 degrees, so it's actually going to be the same number, 77.1 meters per second, as what VOI was. So in this problem, even if you mixed up sine and cosine, you wouldn't get the wrong answer because they're the same value. And then the fourth fact we need is the time that we got from part A, 15.7 seconds. So those are the facts. Step number 2 is to pick the correct equation. The only thing I didn't write down was VFX. So I'm going to use SX equals VOXT plus 1/2 AX T squared. Step 3, there is no step 3 because we're solving for SX and it's already solved for SX, but I can't eliminate the fraction term. And then, so there is no algebra. So step 4, SX equals VOXT. I'm going to put in 77.1 meters per second and 15.7 seconds. So this is going to give me a crazy answer. And 1,210 to 3 significant digits. Might be 1209, but I mean to 3 significant digits it would be 1210 meters. So there is your answer for part B. Now if I were solving for part C, I'll do it in a different color. I'm looking for maximum height, so I know I'm using my facts in the y direction. I'm still going to use VOY. I already solved it above, so I'll just write it as 77.1 meters per second. My AY is negative 9.8 meters per second squared. I actually know that at the maximum height, the final velocity is going to be 0 meters per second. And I know if I want to use my time as one of my facts, I can use that. Half of 15.7. So half of 15.7 would be my time. 15.7 seconds divided by 2. And that's going to be like, what, 8.85 or I mean 7.85. Yeah. 7.85 seconds would be the half. Now, and I'm looking for SY because that's the height. So I have a few choices here because I know everything. I know VFY, VOY, AY, T, so I can pick whatever I think is the easiest formula to solve for this. And I'm going to use, I guess, if I use this formula, SY equals VFYT minus 1/2 AYT squared. If I use that as my formula, I don't have to rearrange it because the unknown is already solved for SY, and VFYT is 0 because VFY is 0. So I can just go right. I don't have any algebra to do if I use this. Again, you don't have to. You can pick another one. But SY is going to be minus 1/2 AYT squared. So the minus 9.8 meters per second squared, and the minus here will cancel the minus this, so I will get a positive answer. And then the time, I have to remember to use half the time. You don't want to use the full time, or you will overshoot it by a factor of 4. Because since this number right here is being squared, if I had double the number, it would be 4 times the value of that. So solving this, and this will get you the maximum height, which came out to be 303 meters. So that's how you would do. That would be a 30-point problem, what I just did. There was an A, a B, and a C. So each part, and like I told you, when you're doing these problems, try and just put the facts that are specific to the problem that you're doing. It makes it much easier for me to correct. Like, don't just have them all in part A. When you get to part C, put whatever facts you're going to use there.